Greetings, my name is Clivin Geju, registration number 19BCE1480, a student of VIT Chennai, and in this video I will be talking about the a priori algorithm, give one example of how it works, and show how you can apply this algorithm for any data set in the RapidMiner software. So, what is a priori algorithm? So, the a priori algorithm uses frequent item sets to generate association rules, and it is designed to work on the databases that contain transactions. With the help of these association rules, it determines how strongly or how weakly two objects are connected. This algorithm uses a breadth first search approach and a hash tree dataset to data structure, to calculate the item set associations efficiently. It is the iterative process for finding the frequent item sets from the large dataset. This algorithm was given by R. Agarwal and Srikanth in the year 1994. It is mainly used for market basket analysis and helps to find those products that can be bought together. It can also be used in the healthcare field to find drug reactions for patients. Now, what are frequent item sets? Frequent item sets are those items whose support is greater than the threshold value or user specified minimum support. It means if A and B are frequent item sets together, then individually A and B would also be the frequent item set. So let me give a quick example of what I'm trying to talk, what frequent item set is. So now in this example, I've put two sets A and B. A contains the numbers 1 to 5 and B contains the numbers 2 and 3. So now as you can see in both the sets you have 2 and 3 as the common numbers. So in this case we would call 2 and 3 as the frequent item sets for A and B. So now that I've given an explanation of what frequent item sets is, let me straight go to the steps of the a priori algorithm. So the first step says determine the support of item sets in the transactional database and select the minimum support and confidence. Second step, take all the supports in the transaction with higher support value than the minimum or selected support value. Third step, find all the rules of these subsets that have higher confidence value than the threshold or minimum confidence. And the fourth step is sort the rules in the decreasing order of lift. Now I will give an example of how the a priori algorithm works with an example and explain the steps as I walk you through the example. So let me just share that now. So now, in this example, so now let's suppose we have this data set that has various transactions, and from this data set we need to find the frequent item sets and generate the association rules for using the a priori algorithm. So in this, what we have here is the 9 transactions, and it shows you what are the item sets. So from this, by skimming, you can see that we have A, B, C, D, and E as the item sets, and each transaction have their own item sets which has been transferred. And also what is given is that minimum support is 2 and the minimum confidence is 50%. Now, so let's go with the first step, which calculating C1 and L1. Now I'll tell you what C1 and L1 is here. So in the first step, what we will create is a table that will contain the support count. So support count here I mean is the frequency of each item set individually in the data set, in the transaction data set. So you will create a table that contains this for each item set in the given data set. So this table will be called the candidate set, or C1 for us in this case. So that is this C1 table that is seeing exactly right here. So now what is L1? So what we do is we will take out all the item sets that have a greater support count than the minimum support. So the minimum support that we have is 2. So we have to take out the item sets that have greater than that value. So this will give us the table for the frequent item set L1. So since all the item sets have greater or equal support than the minimum amount, except let's say except E here, so E's item set will be removed. So with the rest you will be creating the L1 table. So now step 2, we will create the candidate generation for C2 and L2. So we're so it's somewhat similar as the annotation suggests. So what we do is we will be generating C2 with the help of the L1 table. So in C2 we will create the pair of item sets of L1 in the form of subsets. So that's what you're seeing on the left side here, A, B, AC, AD, etc. After creating the subsets, we will again find the support count for the from the main transaction of datasets. That is how many times these pairs have occurred together in the dataset, in this dataset. So that will give us the table for C2, which you can see right here. So you have AB occurring 4 times, AC occurring 4 times, etc., etc. And then we will compare the C2 support count with the minimum support count, which is 2, same as what we have shown in the example in the beginning. And after comparing, the item set with the less support count will be eliminated, and the remaining will be considered as the table for L2, and that is this one exactly over here. You can see the ones that is AD and CD is removed, the rest has been kept. So, and now the next step is your candidate generation for C3 and L3. I haven't written it here, but that's what the next step is. So for C3, we will repeat the same two processes like for creating C1, C2, and L1, L2. But now we will form the C3 table with subsets of 3 items together this time, and we'll create the support count for the data set. So that's what this table is, A, B, C, B, C, D, based on the L2 table. So this is the L2 table. So we'll be creating the C3 table for the help of L2 table, and this is what the support count that you'll get. Now we will create the L3 table after this. So as we can see, there's only one combination of item set, that is support equal to the minimum support count. So remember, our minimum support count was 2. So in this case, you can see only ABC fitting that. So L3 will only have one combination, which is ABC. So we stop there. Now step 4, finding the association rule for the subsets. So to create the generate the association rules, first we will create a new table with the possible rules from the occurred combination A, B, and C. For all the rules, we will calculate the confidence using this formula that I've written here. And then after calculating the confidence value for all the rules, we will exclude the rules that have confidence less than the minimum threshold. So the minimum threshold in our case was 50%. So if there's anything below that, we will not be considering it. Now, after generating the rules, we will get this table over here. Actually, I've removed the last 3 rows over here because it didn't fit the minimum value. I'll just show you quickly what those 3 were first, so you'll have an idea of what I removed. So this is the table actually. So in this table, as you can see, based on these rules, it will show you what is the confidence. So we have the first 3 having 50%. So the fourth one has 40, third one has 33%, and last one has 28%. So we will only consider these 3 for the association rules and not these 3. So that's why I have removed these 3 tables. So that's how about a priori algorithm works. So now let me tell you what are the advantages and disadvantages for the a priori algorithm. So some of the advantages is that, one, it is an easy to understand algorithm. So hopefully with the example I was able to explain how we're creating the different tables and then creating the association rules. It wasn't too hard for me to understand when I was preparing this for this video, and I didn't find it quite hard also to explain it. So that's kind of one advantage for this algorithm. The other advantage that I can talk about is that the join and prune steps for the algorithm can be easily implemented on large data sets. So since in our case we had like a data set of 9 transactions and 5 different items that we were dealing with, it wasn't too hard and it kind of got over quickly as well. We just had to create like 3 tables, 3 candidate tables and 3 frequent item sets table. So like that, if we had more and more data sets and more transactions, it will only follow the same steps, and some of them might even get over within a couple of steps, so just within 10 steps. So it is not that hard to execute. But having said that, even there's a lot of disadvantages as well for the a priori algorithm. So one thing is that it works slow compared to other algorithms because we have to create a lot of tables and then you create the association rule, which is which is quite slow. It is in this case for like some other algorithms. Another disadvantage is that the overall performance can be reduced as it scans the database for multiple times. So as you had noticed, before creating the C2 table, we had to scan through the L1 dataset. Create L2 table, we had to scan C2. to create the C3 table you have to scan L2, and then for L3 you have to scan C2. So it answers, if you consider with more items and more transactions, it's going to get more complex, and you keep it gets stretched, you can say. So and also that another problem with the a priori algorithm is that the time complexity and the space complexity of the algorithm is O to the O of 2 to the power d, which is very high. So in our case here, d here represents the horizontal width present in the database. So now in the example that I've given, the horizontal bit was quite small. So 2 to the power of, and since it's a small number, it was fine, it was manageable. But like in the case if you have tens and hundreds and thousands of items and hundreds and hundreds of transactions, that now that d value will increase, and since it's 2 to the power d, you can see that the number as the number d gets larger, the time and space complexity increases exponentially, which is another big problem with the a priori algorithm. So that's what all is there about the a priori algorithm. Now I will show you how you can work on it on the RapidMiner software. So now the data set that I've used is the iris data set. Yeah, before that, let me tell you how I actually set this up before when I explained the how this works. So first what I did was I created a separate repository, that is the machine learning repository. In that I created two files, one is data and one is processes. In the data file, I have added the iris dataset, and this process, and what you see right here is one process, because you're running it through a set of nodes with the data set, and you're trying to work some functions on it, and you're trying to get a result. So for that, you can refer to this as a process. So that's how you do it. And for in order to know how to import data, as you can see on the top left segment over here, you can click on import data, and you can select where you want to take your data from, and then you get to store it there. There are some other steps to follow. This they want to confirm whether the data has a header or not, or if it's a CSV file. Sometimes there are in some cases where it's not comma separated; it's separated by spaces or tabs or colons. So those are the steps are there. So you have to select accordingly based on the data set that you have selected. So after that, what I've done is now I have loaded the data set here. So now we use the FP growth node over here. So this one actually is used for calculating the frequently co-occurring items in the transaction database, which is something that we need, because with that only will we be able to create association rules for it. But the problem is we can't connect it directly, because FP growth works on binomial data and not the data, and can't handle the current state of the data set that we have in the iris data set, which is a CSV file. So what we do is we use the discretize node here, which will convert the data to nominal data, and then we use the nominal to binomial data converter to convert the nominal data to binomial data. Also, if you want to know how to get these, you can just directly search for it here on the bottom left corner in this operator session. So you can search for discretize and you'll get several ways. So in our case, since we're dealing with frequent item sets, so the keyword here is frequent. So when you have to discretize, in this case we have to discretize by frequency and not by user specification or entropy. That is actually unrelated to our situation here. So I found that node using that way, and then I searched for nominal to binomial this way, and I got it over here. And then FP growth, I just searched for it directly. FP growth, there's only one thing. And then again, so after we converted into binomial, we connect to FP growth, and then from FP growth we connect to create association rule. So again, you can just search for that association rule. Yeah, exactly, that's there. And then you connect it to the result. So now after you made all the necessary connections, you click on run. After it runs, you'll get this results page, what I like to call it. I'm not sure what the correct term is, but you get your results after the process is run. So you get it in the data form for database exactly like this, and then you can have it in the form of a graph, and then you can have it as a description, like a notepad kind of description. Yeah, so now for example, these are the association rules. So if you consider attribute 3, then you will also consider buying something from attribute 3, then you will consider buying something from attribute 4 and attribute 1 as well, and the confidence for that is 0.827 or like 82.7%. So now in this data form, how do we consider is we'll just take one situation from each case and see how the association rule works actually. So now what you see is that when you consider taking attribute 4, like when you want to buy something from the attribute 4, like when you consider that, there's a likely chance that you will consider buying something from attribute 3 and attribute 1 as well. So now with that we get to see two numbers here. One is the support value number and one is the confidence value number. So we have it as 0.413 here and 0.861 here. The support value here indicates how frequent items how frequent these items appear in the data set, and the confidence value will tell you how it shows how true is the statement. So the statement that I gave was that when you buy something from attribute 4, it is likely for you to buy something from attribute 3 and attribute 1. So it tells you that it is this much, we can say 86.1% true that this will occur. So that's how it works, and you can see this. That's how it like that for. See now here also, when you consider something from attribute 1, you consider something from attribute 3 and 4 as well. So here also you get to see the same thing. So that's how this works. So and now if you want to go back to your design, you can just click on design. You'll see that I've all the process run successfully. There wasn't quite any errors, and that's how you can try using work using a priori algorithm in the RapidMiner software. So with that, I would like to conclude with this video. So in this video, I had explained what a priori algorithm is. I told you what are the steps behind it. I gave an example showing how those steps work with the example, and also I have shown you how you can try implementing this a priori algorithm on the RapidMiner dataset, and also giving you steps onto how you set up that process, and then how you input the data, how you search for those nodes, how you run the process, how you should understand the process, and what are the important terms that you need to know when you're running with the RapidMiner software. So with that, I would like to end with the video. Hope I have made, I was able to deliver what I wanted you to understand from this video. So for that, thank you.